Okay, let's factor some trinomials. First thing we're going to do though is we're going to expand some binomials to look for clues to help us factor our trinomials today. And the reason is this: we know that if we have two binomials multiplied together, the result is going to be a trinomial. So for the first one here, I'm going to get x squared plus 4x plus 3x plus 12 if I expand that out using FOIL. And if I gather the middle terms together, x squared plus 7x plus 12. So two binomials together, multiplied together, give a trinomial. And what we're going to do is take this trinomial and factor it back into two binomials like this. Second example here, same thing. If I multiply this out, it's x squared minus 5x plus 3x minus 15, or x squared minus 2x minus 15. Again, another trinomial here. And last example, same, x squared minus 2x minus 7x plus 14. And again, another trinomial, minus 9x plus 14. So what we want to do for today is take these trinomials, factor them, get them back into the original form here of two brackets like this, two binomials up here, okay? So, how do we do that? We have to decide, where did these numbers come from? Where did the 7 and 12 come from? And the negative 2 and negative 15, negative 9 and 14. They came from, well, in this case, the 12 comes from 3 times the 4. And the 7 comes from the outside multiplication and the inside multiplication, the 4x and the 3x. So we can see here the 7 came from the addition of 4 and 3, and the 12 came from the multiplication of the 3 and 4. And exactly the same pattern for your other binomial multiplications as well. This trinomial resulted from 3 times negative 5 for negative 15, and the middle terms are added to get negative 2. And exactly the same over here. So when we're dealing with factoring for trinomials, what we want to be able to do is decide, how do I build these brackets up here based on the trinomial that we have down here? And the result is basically the middle number comes from a sum of the two middle terms, and the last number is a product of the last two numbers. So if we're going to factor any trinomial that looks like this, we have to think of numbers that multiply to the last number and add to the middle number. So if we can keep that in mind, then we should be able to factor any trinomial. So here's some examples. We've got a trinomial here. We know that every trinomial will factor into two binomials, and we can start with the brackets there. I've got x at the beginning here because we know that x times x is x squared. Now we have to think of numbers that multiply to 8 and add up to 6. Now it's not too bad here. Numbers that multiply to 8 are of course 1 and 8 and 2 and 4. We have to pick the correct pair that add up to 6 in the middle. So that will be 2 and 4. And all you need to do now is put in the correct signs. We're trying to get to positive 6, so the outside multiplication is 4, the inside is 2, or 4x and 2x. So I need positive 4x on the outside multiplication and positive 2x on the inside multiplication. And just a final check with the overall trinomial, x times x for x squared, 4x plus 2x is 6x, and then 2 times 4 is 8, and we know we've got it correct. So you should always be able to write down an answer, put in the signs, check it for yourself just by multiplying it out, and come up with the original question. Over here, the next question, same. I can start out with a couple of brackets and fill in the first part being x's. We have to think of numbers that multiply to 18 that add up to negative 11. And with a little bit of thinking, hopefully you came up with 9 and 2. We now have to come up with the correct signs. We need negative 11 in the middle, so that should be negative 2 and negative 9. Negative 2x subtract 9x is negative 11x, and then a final check, negative 9 times negative 2 is positive 18, and that one's finished as well. Just while I'm thinking about it, does it matter which order you put the numbers in? Can I put the 2 in the first bracket and the 9 in the next bracket? Yes, of course you can. Multiplying two numbers together makes no difference the order that you multiply them. So these could be reversed if you like, and these could also be reversed if you like. For C, same thing. Write some brackets here with some x's at the beginning. We need to think of numbers that multiply to negative 21 that add up to negative 4. And with a little bit of thinking, hopefully you can come up with 7 and 3, or 3 and 7 in the reverse order, that's fine. Put in the proper signs though. I need positive 3x on the outside and negative 7x on the inside. So 3x subtract 7x is negative 4, and negative 7 times positive 3 is negative 21. For D, exactly the same. X is at the beginning. Numbers that multiply to negative 42 that add up to negative 1. You can put the 1 in there if you need to. That should be 6 and 7. And I need a negative 1 in the middle, so that should be negative 7x plus 6x, and positive 6 times negative 7 is negative 42. That one's good too. Down here it looks a little different, but don't worry, it's exactly the same. We're still going to get two binomials here. This time, instead of putting the x at the beginning of the bracket, we're going to put the x at the end of the bracket. So I'll put the x's here, but we're still going to have to think of numbers that multiply to 12 and add up to negative 7 in the middle. So everything's kind of just in the reverse order. The process is still exactly the same. Numbers that multiply to 12 that add up to negative 7, that should be 3 and 4. And check the signs. I need negative 3x subtract 4x. Negative 3 subtract 4 is negative 7, and negative x times negative x is positive x squared, and that works out as well. Okay, there are ways of making this a little bit more difficult, and I'll show them to you now. To factor these other trinomials, it's still exactly the same process, so it's not really more difficult, it just looks a little different. So to factor this example here that I've got, you can see that you have an x squared at the beginning, but also a y squared at the end. So to write our brackets then, we're going to write the x at the beginning of the brackets still, but we now need to write a y at the end of the bracket so that y times y gives the y squared at the end of the question. The process still is going to be thinking of numbers that multiply to 15 that add up to 8, and hopefully you can come up with 5 and 3. And putting in the signs then, just checking, we've got 5xy on the outside and 3xy for the inside. 5xy plus 3xy is 8xy, and positive 3y times positive 5y is 15y squared. This one here also a little bit different. You can see that at the beginning we have x squared and y squared. So I need x's at the beginning and also y's at the beginning. X times x for x squared, y times y for y squared, and the process for factoring is still thinking of numbers that multiply to 24 that add up to negative 10, and that's going to be 6 and 4. With the signs, I need negative 10 here, so negative 4xy subtract 6xy is going to be negative 10, and then negative 6 times negative 4 is positive 24. Last part here, just combinations of factoring. So we're going to combine common factoring, which we've already done with the trinomial factoring that we've done today. You know that you're going to have to do some combination factoring because in the first example here we can see that the number in front of the x squared is a 2. It's something that's not a 1. So it could be a 2 or a 3 or a 4 or 5, whatever it happens to be. We haven't factored any of those questions today, with the number here being something other than a 1. So when you see a number here that's not a 1, then it's your clue that you're going to have to do some common factoring first. And you can see there's a common factor of 2 for all of these numbers here. So if I divide that out, x squared plus 13x plus 30 remains, and we can then factor this trinomial as we factored all the other trinomials today. Think of numbers that multiply to 30 that add up to 13. Just copy the 2 down that we've already common factored. Write your brackets. X is at the beginning. Numbers that multiply to 30 that add up to 13 would be 10 and 3. And the signs should be 3x on the outside, 10x on the inside. 3x plus 10x is 13x, and 10 times 3 is 30. And that one's done. Last one, same type of question with a combination type of factoring. You can see again the number here is not a 1, it's a 3. And also you can see we've got a cube as the exponent. Every other one had a square as an exponent to begin with. So not only do we have a common factor of 3, we also have a common factor of x. And if I divide that out, that will leave you with x squared minus x, minus 20. And again, the common factor reduces the question to a trinomial type of factoring. And if we factor now the trinomial, we've got x is at the beginning of the bracket. Numbers that multiply to negative 20 that add up to negative 1 should be 5 and 4. And to get negative 1, I need positive 4x for the outside multiplication and negative 5x for the inside multiplication. And to finally check, negative 5 times positive 4 is negative 20. And that's it. There's other variations of this, but you should see those in your homework, or we'll talk about those in class.